All right. So we started the recording class. This is the first lecture class for the class 9 batch. And today I'm going to talk about not any specific chapter, rather I'm going to talk about a specific idea that is called graph. So usually for all of my O-level batches, the first class I always take is about graphs. How to understand graphs, how to manipulate graphs, how to take data out of graphs, how to convert data into graphs. So and what type of behavior of graphs should be expressed in what type of wording. It's pretty important, really important for you kids to understand that you might have a proper understanding of a graph. You might understand it properly. It works pretty well in your head. But whenever you are trying to express that information in pen and paper, if you mess up your words or if you miswrite those words, then you're going to lose marks. So it's equally important to understand the content and be able to articulate that. So we'll be emphasizing on both of these aspects in today's class. The first thing that I'm going to talk about is what are the different type of equations that we're going to work with. So this is my working version. I always use Microsoft Paint, which is the pretty old app that we have used. I'm not sure about you kids. So the first thing we need to understand that let's have a look at a couple of equations. Do you know this equation? This is a straight line equation that goes to the origin, which is a straight line, which means its gradient is something. Y equals to mx means it's a straight line that passes through the origin. Whereas if I write y equals to minus mx, that is also a straight line that passes through the origin. The difference between these two lines is that this line is going to pass through first and third quadrant. What I mean is that if this is our axis system, this line is going to look like this. Let me just use straight line option because I have the straight line options, and if I can draw it like that from here. So y equals to mx could look like this. It could look like this. It could look like this. It could look any of these parts, but it's gonna be it will always pass through the first quadrant and the third quadrant. Whenever you see an equation like that without any mention of the possible value of the y or x, you have to assume that these lines are potentially infinite. Potentially infinite means there is no end point of these lines. These lines are gonna be as long as you want to draw them. So as big as your graph paper is, these lines are at least up to that. If you make your graph paper bigger, these lines are going to still be continued. So if there's no range mentioned over here, these lines are expected to be as long as up to infinity. But if there is a range mentioned, for example, let's say you are given this equation y equals to mx. Let's say I give you a practical equation. Let's say I'm going to give you an equation y equals to 3x, where x equals to let me write a range for this. Let's see if I write where let's say minus 10 less than equals to x less than equals to 10. Do you guys understand the meaning of this symbol, this writing? What does it mean? Minus 10 less than equals to x less than equals to 10. This means that the value of x can be from minus 10 all the way up to positive 10 inclusive. Inclusive means these boundary values minus 10 and 10, they are both equally acceptable. Whereas on the other hand, another different expression for this kind of range values can look like this. It can also look like this: minus 10 less than x less than 10. If you have a range value like this, that means that the value of x is from minus 10 to positive 10, but without the boundary values, which means x is never going to be as small as minus 10. It's going to be pretty close, but minus 10 is not included. Similarly, x is always going to be close to 10, but not exactly 10. The value of 10 is in between minus 10 and 10 without the boundary values. And if you have equals to sign, it means this is from minus 10 to positive 10, including the boundary values. So these are the type of range that we might have mentioned, but in your physics, this is not very common. So we are not going to be highlighting on this information far too much in our discussion as we go forward. The reason I'm covering this in your physics lecture, because this is something that I need to tell you. I prefer to tell the kids that if this kind of a range is mentioned, then these lines will be a finite line. For example, for this case, this line would be, this graph should exist from x-axis value minus 10 all the way up to positive 10. But if a range is not mentioned, potentially these lines are infinitely long. So this is how positive gradient lines look like for y equals to mx. And similarly, you can have, if you have y equals to minus mx, those lines might look like this. So those would be lines which pass through the origin, but those have a negative gradient. So these are these orange lines they are also passed to the origin, but with negative. So straight lines with negative gradient, they with y or y equals to minus mx. This represents the straight lines which pass through the second and the fourth quadrant. Do you kids understand? Yes.
Sir,
Yes.
can you explain the -10, the part thingy?
Here.
Yeah.
Oh, this means that if I draw a number line, let's say if I draw a number line, let's say here you have 0. Do you guys know number line?
Yes.
Yes, sir.
You see a number line, let's say you have 0 and then you have 1, 2, 3, 4. I'm not drawing all the values. Let's say here is 10, positive 10, and up over here we have, let's say, minus 10. If you have this expression, it means all the numbers from minus 10 to positive 10 can be a value of x, including the boundary values. Including the boundary values means x can be as small as minus 10 and as big as 10, and all the values in between.
Yes.
Whereas this one means s will be always bigger than minus 10. Now the word bigger means it should be bigger. Now it can be minusculely bigger or minutely bigger than that. For example, let's say minus 9.999999999. That number is definitely slightly bigger than minus 10. That can be a value of x, but x will never reach that exact value of minus 10. The way we verbally explain or state this relationship or information is that the value of x ranges from minus 10 to positive 10 without the boundary values. Boundary values means minus 10 and 10. In this case, the x is not equals to minus 10, x is not equals to 10, but anything in between is acceptable. That's the difference between the equals to sign and the equals sign being present or equals to sign not being present.
Yes, sir.
Yes.
So do you guys understand the reference that I'm trying to make every single, I'm talking about that first quadrant, second quadrant, third quadrant, fourth quadrant. Do you know this thing, everyone? This quadrant division?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So this is a type of equation. So this is one type, because the most simple form of equation for a line. The next version can be y equals to mx plus c. Now, because we have this expression, we can have a lot of different type of equation over here. So I'm going to write 4 different equations. For example, y equals to mx plus c. I can write, let's say, y equals to minus mx plus c. I can write another expression, y equals to mx minus c. And let's say I can write y equals to minus mx minus c. So I have used minus and plus both of the signs. So there are 4 possible variation for this expression. So y equals to that, y equals to that, y equals to that, y equals to that. So how are we going to work with this kind of equation? What kind of graph should we expect to whenever we are provided with a graph with equations like this? This is something that you need to understand. Y equals to mx gives us the equation where we have the straight line that passes to the origin, period. There is no x-axis intercept or y-axis intercept. Intercept means cutoff. That means that the line would not pass to the origin. It will cut off the axis at any other point other than the origin. Y equals to mx plus c. Let's say let's say for the sake of discussion, let me number those equations. Let's say 1 and 2 and 3 and 4. I'm not giving values over here because I'm trying to draw a sketch of this general information. I'm not giving a specific value. For example, if this equation was written as y equals to 3x plus 2, then that would mean a very specific straight line. But by writing y equals to mx plus c, I'm covering the general behavior of all the straight lines which follow this equation expression. For example, if we have an axis system of like this, I'm going to be drawing all of these graphs in a single graph system just so that you can contrast. I'm not going to draw them on different places. So keep your eyes peeled and try to understand what is happening. Let's say I'm going to first draw the axis system. So I might as well use a bit thinner line. So let's say these are y-axis and these are x-axis. So y equals to mx plus c means that this graph has a positive gradient and it has a positive y-axis intercept. What do we mean by positive y-axis intercept? Try to have a look at this equation. If you place x equals to 0, do this math in your head. If you place x equals to 0, how much should we be left with? If x equals to 0 is placed, then 0 multiplied by m, whatever that value is, m is, it's a positive number over here. Together, this whole thing will become what?
0.
0.
You'll be left with y equals to c. This essentially means y equals to mx plus c we'll have an expression, or we'll have a intercept on the positive y-axis. So somewhere on this part, there will be a cutoff of this point, and also this is y equals to mx plus c, which means this will have a positive gradient. So positive gradient means lines which are tilted like those black lines, not like those orange lines. So one of the general symbol for graph number 1, let me draw this with, let's say, green, could look like this. Let's say this is our equation number 1. So this is y equals to mx plus c. Is it all right?
Yes, sir.
Positive gradient with a positive cutoff. If I yes, respond.
Sir, can you repeat what you said?
Which part?
About the gradient?
Oh, the gradient part is that. The gradient in this case, I'm trying to represent m as a positive number. Having a positive number means that your line will look like this, or like this, or like this, or like this. So if the line should have a shape that tends to go like from 1 to 3 or 3 to 1 in this orientation. The location of this position can be up and down based depending upon the c value, but a positive gradient means lines should be like this. So they should be going downward left, if I put it that way, or upward right, if you are putting it this way. That is the generic type of lines which have a positive gradient.
So the right side of the line will be always up.
Compared to the left side, yes. Now, I'm saying compared to the left side because, I mean, it is also possible that y equals to mx plus c. For example, this is a graph that I'm trying to show you, that this is a graph for y equals to mx plus c. But let's say, if you ever come across a line that looks like this, let's say in a different scenario, you're given a line that looks like this. You're only given this much of a line. You're only given this much of a line, and you are asked that you are gonna find that, or you are told that the equation of this line is y equals to, let's say, 4x plus 5. Now this might look pretty weird because you can see over here that this line doesn't even have a cutoff on the positive axis. How could it possibly 4x plus 5? The idea is very simple. This equation, this line is represented by y equals to 4x plus 5, means if it was extended up to y-axis, then it would have a cutoff at 5 point. The reason this line looks like a small portion, because it is possible that for this only small segment of a line, maybe we had this logic available, that this straight line y equals to 4x plus 5 maybe was drawn only for a very specific small range of x. Maybe this was drawn between x equals to -3, -2. Sorry, এটা তো coordinate হয়ে গেল, coordinate হবে না. I'm not trying to show you coordinate. Let's say this straight line was only drawn from for this range from -3 to -2. So if you have a situation like this, then you are not going to have the line even going up on the positive side. But the equation of the straight line can still have this expression. The point that I'm trying to make, that your right side would always be above compared to the left side, representing a positive gradient. The line might belong to the negative y-axis, but the line should be slanted to be upward right or downward left. Do I make sense?
Yes, sir.
Yes, Adin.
Sir, I still didn't understand.
একটু আগে যেটা বলেছিলেন সেটা একটু বুঝি নাই, আবার একটু বুঝাবেন?
হ্যাঁ, কোন পার্টটা? তোমার কোশ্চেন নিচ্ছে, ইফাত তোমার কোশ্চেন নিচ্ছে, একটু ওয়েট করো। কোন পার্টটা বলো?
স্যার এই যে লাল কালারের যেটা লিখেছেন ওইটা,
এই পার্টটুকু,
এই পার্ট আর উপরের এই লাল পার্টটা।
আচ্ছা, বলতেছে, লেটস সে you are given a straight line like that, you are given a printed straight line like that, and the question says that the equation of the straight line is y equals to 4x plus 5. You are only given this much part, and along with the this black axis system. Now this information might look wrong, because you can see that y equals to 4x plus 5 means what? This is supposed to have a y-axis intercept, right? Positive y-axis intercept, that is. Y equals to 4x plus 5 means what? What is supposed to be intercept on the y-axis? 5. But the question says that this is the straight line that you have available. Now, and the equation of this, and the equation expressing this straight line is y equals to 4x plus 5. Now, my point is, it is very much possible. What this information essentially tells you, that When x value will be 0, then y value will become 5. So if this straight line was extended up to x equals to 0, it means it could reach up to this point, then this coordinate on the y-axis could be 5. But it didn't happen. Now, if you wonder why this did not happen, why this line looks so much short, the reason might be that maybe for this y equals to 4x plus 5, we might have had a range for the x values. So the range is sort of a range that I have discussed over here. Here. Let's say this straight line was not aimed to be infinitely long, but we gave some range that, let's say, the range for the x might as well be, for what I'm trying to show over here, that the x value might be, let's say, -3 less than equals to x less than equals to 2, which means that you are only going to draw this straight line for this much x coordinate values, which means so what would be the y-axis value for this point? Can we do the mental math? Have it placed -3 over here. How much do you get? 4 into -3.
4 into -3.
-12.
-12.
Plus 5.
-12 plus 5. -17.
So this point can be -7. And this point over here can be how much?
-2.
-2. Have a look. You place the value of x equals to -2. x equals to -2 বসালে কত হয়?
-2 বসাইতে হবে।
x equals to -2 বসাও। বসায় দেখো y ভ্যালু কত হয়?
y should be
-3.
-3 হয় না? Y becomes -3. So it is possible that this line can be limited on the negative y-axis. You can see over here that for all the coordinates of this point, all of these points are minus because it belongs on the third quadrant. But the equation of this thing represents 4x plus 5. It is very much possible. I mean, a line can have an expression like this, but can be limited within a certain segment of the straight line, depending on the logic that will apply on its possible value acceptance. That how long this line needs to be, or how long this line is logically supposed to be. That's what I mean.
Sir?
But at the end, what I say that, just a second, question is to Daro. At the end, what I say is that if you have a shape like this would always mean, if you have a positive gradient, I highlighted this part, if you have a positive gradient, this would always mean that this line would be slanted in a way that it would look to be upward right, or it would look to be downward left. This kind of lines represent positive gradient lines, or something that's like these black lines over here, that goes through approximately from the first quadrant to the third quadrant. So upward right directional lines, or downward left. Or in other words, one of your classmates just described in a better way, that the right side should always be above compared to the left side. That also works. Now, if you wonder why does that happen, because let me elaborate this part a bit more. I'll take questions from you. If you have a question, please raise your hand. I'll give you a floor to ask that question eventually. Just keep your hand raised. What do we mean by gradient M? What do we mean by this expression? How do you define gradient? Gradient of a line is usually defined by this expression: M equals to হচ্ছে del y by del x. Do you know this equation?
What?
Delta y by delta x.
changing y by changing.
No.
Okay, this is how we define. Okay, I'll tell you. No wait. This is how we define the gradient of a line. Gradient of a line means, the whole idea of gradient is that the whole idea of gradient is that how does y value changes as x value increases. Mark my words. এই কথাটা একটু লিখো সবাই কপিতে। আজকে ডেট দাও উপরে, ডেট দিয়ে জাস্ট এই স্টেটমেন্টটা লিখো। সবকিছু লেখা লাগবে না, যেগুলো লিখতে বলছো সেগুলো লিখো। আমি ইভেন্চুয়ালি তোমাদেরকে গুছানো নোটস দিয়ে দিব, বাট এখন যে জিনিসগুলো লিখতে বলছো সেগুলো লিখো। Write this down. Gradient of a line gradient of a line represents gradient of a line represents how the y value changes as x value
gradient of the line represents
how the y value changes as x value increases. Gradient of a line represents how the y value changes as x value increases. Now, I need all of you to understand, look at this sentence and keep a very good look on this sentence. Lock your eyes on this sentence. Have a very good. How did we describe the y value? As the y value changes, right? How the y value changes as the x value, what?
Increases.
Increases. This is a very important bit of information. That whenever we'll talk about the change or the inclination or slope of a curve or a straight line, or when we're going to talk about gradient, we're always going to mean how the y value change happens as x value increases. Or in other words, I can tell you, if you have a look at the video, that we're going to describe a straight line always how the value on that relevant shape of the graph that we are working, straight line or curve or whatever, how that is changing, how the y value is changing as x is increasing. So x is increasing means x value will always happen from left to right. So as we observe for the curve or straight line from left to right, what happens to the y value? So if you have a graph of positive gradient, this will always be that as x value increases, y value also increases. Because have a look, if we want to have a positive value of m, essentially for a positive delta x, if you wonder why positive delta x, because like I said, that x value is increasing. Now delta always means change. The symbol delta in physics always means change, and change always means final minus initial, not big minus small. This is a very important bit you have to remember. These are not essentially something that you would be taught as a part of your theoretical knowledge for a specific chapter. These are general rule of thumbs which you have to understand. Or in other words, I can tell you that there are certain things that you have to take for understanding. For example, if you want to make sense of English, you have to know the alphabet, right? Now, why does an alphabet look like that? For example, A looks like that. Why does A look like that? I mean, that question cannot be answered. Or if you ask a question that why does 2 look like that? Couldn't 2 look like this? You write a random symbol. That question cannot be answered because that's how we define that shape and that's how we work with it. So there are certain basics which you have to understand for the working properly. So one of those basics is that delta symbol in physics always means change. Change always means final minus initial. And this is always. So whenever we mean delta x, in this case, as we have described in the definition, that what is gradient? Gradient represents the change of y value.
স্যার
Yes.
স্যার এই গ্রেডিয়েন্টে যদি x যদি বেড়ে যায় তাহলে কি কোনো y এর কোনো চেঞ্জ হবে?
হ্যাঁ, গ্রেডিয়েন্ট বেড়ে গেলে y এর চেঞ্জ হইতেও পারে, নাও হইতে পারে, আর হইলে পজিটিভ চেঞ্জ হতে পারে, নেগেটিভ চেঞ্জ হতে পারে।
না x বাড়লে কি y কমে যাবে নাকি বাড়বে?
ওই জিনিসটাই আমরা অবজার্ভ করার চেষ্টা করছি।
Sir?
It could happen both ways. A minute, hold up. The part that I have discussed so far, I have only discussed with this equation. So I'm still working with this equation and try to build up the base of the knowledge. So for this discussion, we have defined that m was a positive number. Now, what I want you to understand that delta x was defined as an increase. তার মানে হচ্ছে তোমার x এর ভ্যালু তোমার মনে করো let's say we are working with this straight line and we want to calculate the gradient of this straight line. One of the ways that we can go for is that we can choose 2 different points on this straight line and have a right angle triangle. Can I do a right angle triangle over here? I can, but it's not my convenient orientation. Beautiful. So how can I draw a convenient directional right angle?
আপনি সাইডে এঁকে ফেলেন।
আচ্ছা, আমি হাত দিয়ে আঁকি, কিছু করার নাই। মনে করো আমি এখানে আচ্ছা বড় একটা ট্রায়াঙ্গেল আঁকি, লেটস সে এতটুকু বড় একটা ট্রায়াঙ্গেল আঁকলাম। So let's say this is my point number 1, this is my point number 2. So if you wonder if we observe the change of the x-axis value from point 1 to point 2, let's say the coordinate of point 1 হচ্ছে x1 y1. Do you guys understand how the coordinates are written? Let's say the coordinate of point is 2, 3. It means the first number is the x-axis value, the second number is the y-axis value. So let's say the coordinate of the point 2 is, let's say, x2 y2. Okay, so if that's the case, so if you are trying to calculate the gradient, you would always have to observe the change of y value as x value increases. So you have to choose your first point, which is on the left. Between 1 and 2, which point is on the left?
1.
1 is on the left. So you have to observe the variation of the y variable as you observe the value change from 1 to 2 from left to right. So that would essentially mean that your delta x should be x2 minus x1. And in all cases, this is supposed to be a positive number. See if you can agree with this one, this information. Because x2 is always supposed to be larger and x1 is always supposed to be smaller. So this value is not supposed to be negative in a regular case. In a regular case, there is a different version for this. Just a second. There is a different version for this, which I'm gonna cover. আমি চাইলে এটাকে x1 minus x2 লিখতে পারতাম, but
What is
I have muted you all because there was noise coming in from from one of your or multiple channels from your sides. If you are not asking a question, preferably keep your channel muted. There is an option in Zoom that it is a voice sensitive app. So you sometimes that if you talk to, even to your mom or to your dad or anyone else, not through the channel, Zoom might detect your voice latency and it might unmute yourself automatically. So just be careful to keep yourself muted if you're not asking me a question. And I have two of the kids having their hand raised. I'll take your question in a bit. Just একটু আমি একটা part বলে নেই. So what I'm trying to mean is that as x value increases, we're going to go for this one. So we have placed x2 minus x1, and also for that part we also have to write delta y. In that case, delta y should also be final minus initial, which would be y2 minus y1. So for a positive gradient, if you have a look, this is a number which is supposed to be positive. If this number has to be positive, and where we have already defined this denominator as a positive number, logic tells us that this numerator should also be positive, because the ratio of two positive numbers can only give you a positive number. If any of this number is negative and the other one is positive, you cannot get a positive number. Ratio of two positive number gives you a positive output, or ratio of two negative numbers can also give you a positive output. So which means delta y should be positive. Delta y should be positive means your value of y should go upwards as you observe from point 1 to point 2. Now let's check it out. Is it the correct scenario? I'm going to be using blue for my reference. So let's say point 1, this one's y coordinate was located here, somewhere over here. Point 2, this one's y coordinate is located over here. So as you observe from x value, so x1, this is and this is your x2. So this is on the grid, this is your x1 and this is your x2. As you move from x1 to x2, your y value changes from y1 to y2. So what is it that you are having? You are having the y value is increasing as x value is increasing, ultimately giving you the idea of a positive gradient. That's what the idea of gradient is all about. That how does the y value changes as x value increases? Okay, I'll take questions now. একজন করে আদিবা আমিরা বলো।
Sir, is it possible for x to go in a negative direction?
It is possible for x to go in a negative direction. In that
So the
case,
gradient will be negative.
Yeah, in that case, you have to change both of these expressions simultaneously. What the definition that I've given you stands true, but because this expression will be ultimately what? I mean, if I take these equations over here on the left side, because I don't have much workable space on the right, I can write this equation as y2 minus y1 divided by x2 minus x1, right?
Yes.
So mathematically, I can also write this expression as y1 minus y2 divided by x1 minus x2. That's not essentially incorrect.
No.
That's not essentially incorrect. So you can also calculate the gradient by this equation if you have to, from the aspect or the information available to you. That is also correct. But the way we define the gradient is how the y value changes as x value increases. This is something that we do to avoid confusion.
If a larger portion of the segment is associated to the left side, then the gradient will come negative.
No, it's not about how much portion is located where. It's about which side of your line is above which side. For example, if your left side is below and right side is above, this would be a positive gradient. This line might be located anywhere. This might be located here. This line might be located here. This line might be located here. This line might be located like this. But just by looking at the shape, if you see that your left side is below and right side is above, then it will have a positive gradient, and vice versa. If you have a line that looks like this will have a negative gradient.
Oh, okay. So it doesn't matter due to the location.
No, it doesn't depend on you. That's exactly what I was trying to describe to you for this part. That the graph, that the equation of the straight line might be looking like this, which tells us that this is a graph of positive gradient. But you can see that this line exclusively is existing on the negative points. Is that acceptable? The answer is yes. It's very much acceptable.
Okay.
The position is not important. The alignment is. That's the part that you have to understand differently.
Okay.
Okay. Adiba. Okay, this was Adiba. Ryan Shakur.
Yes, sir. X2 minus x1 এর জিনিসটা বুঝতে হবে।
Yes. Delta x means the change. Change means final minus initial. So because the definition tells you that as x value increases, which means you have to always start from the smaller x value to the higher x value.
Sure.
That's what we mean by increase. So if you look at this graph over here, this was your first point, this was your second point. So this is supposed to be your final x coordinate. This is supposed to be your initial x coordinate. So delta x should be obtained by subtracting x2 minus x1. Final minus initial, because you are observing the change of this behavior from here to here as x value is increasing, not the other way around by definition.
Yes, sir. Thank you.
Okay, sir.
Yes, sir.
There are a couple of more hands raised over here, but I believe you got your question answered. That's why you lowered your hand. Am I correct?
Yes, sir.
Beautiful. So you can see that my working space is becoming pretty messy. That's exactly how I teach for most of my parts. So unless you are really keeping your eyes peeled and you're really involved in the class, if you join halfway in the class, looking at a board like this, or the whiteboard also look like this whenever I go through this kind of discussions. Looking at a board like this randomly can give you scare. But rest assured, if you ever have any question, feel free to ask me those questions. I'll try to make sense to you as best as I can. No worries.
Sir,
Yes.
sir, can you explain the part where you wrote delta change equals to final minus initial?
Oh, this is the basic meaning of delta in all cases of physics. Delta always means the variation of a variable, and delta always means final minus initial. It does not mean big minus small. It's not difference. Difference means big minus small. Change means final minus initial. I'll give you an example. Let's say the temperature of an object changed from 10 degrees Celsius to 30 degrees Celsius. Okay. If I ask you, what is the change in temperature? Your answer should be 30 degrees Celsius, 20 degrees Celsius, because you do the subtraction, final minus initial. If I ask you, what is the difference of these two temperatures? Your answer can be also 20 degrees Celsius. Works. Let's say in another scenario, the temperature dropped from 30 degrees Celsius to 10 degrees Celsius. So let's say this is a different scenario. If that is the case, if the temperature drops from 30 to 10 degrees Celsius, if you ask what is the difference of these two temperatures, that answer will be 20 degrees Celsius. No minus is mentioned. But if it is asked that what is the change in temperature, then the delta theta, change in temperature, that has to be given by final, that is 10, minus initial, that is 30. So your delta theta will become minus 20 degrees Celsius. That's what I meant.
Yes, sir.
This example makes sense, right?
Yes, sir.
Beautiful. So change always means final minus initial. So you will always have to place the final value, irrespective of big or small, in the front, place the subtraction sign, and then the initial value, irrespective of big or small. Difference means big minus small. Change means final minus initial. Are we clear up till now?
Yes, sir.
Yes, sir.
স্যার
হ্যাঁ বলো একজন করে
স্যার আমি
বলো।
জাস্ট এটা জানতে চাচ্ছি যে আমার কোশ্চেনটা শুধু অনেক সিম্পল। কোশ্চেনটা হলো যে এমটা কি বোঝাতে চাচ্ছেন? এমটা
M is the generic symbol for gradient for typically all sorts of straight line equations. M is the sure, no problem. Acha. So that was that. Acha, I'll be expanding my workspace. This is amazing because this whiteboard doesn't have any limit. I can just
Sir?
go by yes.
You have written in number, there was an equation y equals to mx minus c.
Yeah,
Is
I'll be
there any
covering.
reason?
Yeah, I'll be covering all three of them. I was just covering the first one and going through the basics of the gradient discussion.
Okay.
I'm about to start on these other parts. So the point that I was trying to make is that if your gradient is positive, your line should look like this. If your gradient is negative, your line should look like this. We are clear about this much part, right?
Yes, sir.
All of us. And also, if your C is positive, then that line should cut the y-axis on a positive side. If your C is negative, then that line should cut the y-axis on the negative side. So if I just try to draw all of these lines over here in a fresh version, let's say I'm gonna draw the coordinate system one more time because that thing is pretty messed up. Oops. Black, straight line. So assuming all of these lines are infinitely long, so we are not going to draw a small segment. What I discussed over here, I'm going to be drawing long lines over here just to make sense with you. So it is possible that equation 1 can look like this. Then this is equation 1, positive m with positive c. Then we have minus mx plus c. It means this one should be a line that is slanted like this, but it should have a positive cutoff. So this line might as well look like this. Now, if you wonder, sir, is it there a possibility that these two lines should be exactly the same since you have mentioned the C? Well, I am not essentially meaning that C value to be equal for all the equations. I'm trying to give you an idea for the sketch graph. Sketch graph means that what would be the shape of the graph, not the exact coordinate. I'm not trying to show you the exact graph with actual numbers. I'm trying to give you an idea how the graphs are going to look like in terms of orientation and in terms of y-axis cutoff. That's the information that I'm trying to convey here. So it might as well be that these two lines might be exactly equal if for these two equations both of the C values are equal. But if the C values are not equal, you might as well have this line like that, or you might as well have this line like that. But you can never have this line over here. That will be wrong. Equation number 2 cannot be like this because this cutoff is in which side of the y-axis? Negative side of the y-axis.
What does C denote for?
Yes.
What does C denote for?
C denote for the y-axis cutoff, or we can say y-axis intercept. That's the word.
Okay.
Y-axis intercept.
লাইনটা কি স্যার যে ইকুয়েশনের উপর ডিপেন্ড করে নাকি আবার?
লাইনটা সবসময় ইকুয়েশনের উপর ডিপেন্ড করে।
মানে যদি মনে করেন mx - c হয় তাহলে কি হইতো?
এই যে আচ্ছা দেখাচ্ছি। So this was line number 1. This is line number 2. Let's go for mx minus c. That is line number 3. So this is this equation 3 is mx minus c. That is positive gradient with negative cutoff, negative intercept. So positive gradient means the line should have look like this. It should have a orientation like line 1, but the cutoff should belong on the negative y-axis. So that line might as well look like, let me draw it purple, like this. Now I'm showing a different gradient, but what I'm essentially making sure that this line is having the y-axis cutoff on the negative side. You see, this much is the cutoff. So if I label values for equation for line number 1, this is the plus c value. For line number 2, this is the plus c value. For line number 3, which I didn't label yet, let me just label that. Let's say this is our line number 3. So for line number 3, this is the minus c value, which means it is having the cutoff at the negative y-axis. In the similar way, equation number 4, minus mx minus c, which means it will be aligned in this orientation and have the cutoff on the negative y-axis. That line might as well look like this.
Yes.
Negative gradient with negative cutoff. That one might be 4. Are you clear with these expressions up so far?
Yes, sir.
What is the gradient and the cutoff for the graph number 2?
Graph number 2 is this one. So it is having a positive cutoff on the y-axis, but the gradient is negative because as the x value increases from left to right, y value is becoming less. So for a positive delta x, you're going to have a negative delta y.
Sir?
Yes.
So y equals to mx plus c is basically the equation for the tangent.
No, tangent comes a bit later. I'm tangent একটু পরে আসছে। Curve যখন বলবো তখন tangent এর পার্টটা বলবো। Y equals to mx plus c is one expression for a straight line, one equation for a straight line. That and now a straight line can be tangent to a graph if you plot it to be a tangent, if you draw it to be a tangent. But I mean, if I go in a much simpler version, that straight lines are straight lines. straight lines drawn as tangents are tangents.
Yes.
সরি
Makes sense?
যদি মানে বলা হয় যে the two lines intersect each other মানে কি দুইটা অ্যাক্সিসে কি মানে intersect মানে লাইন পার্ট করবে মানে যদি বলে হয় যে intersect at 2 points
First of all, two straight lines can never intersect at 2 points.
না
Because
যদি
if you-
intersect করে না একটা মানে ম্যাথ বলে না
হ্যাঁ,
যে
সমস্যা নেই, বলতেছি।
intersect
I get your point. If the two lines intersect, they will always intersect at one single point, not at multiple points. That's not because they are straight lines. So they are going to be converging onto each other up to a certain point, up to the intersection point, and beyond the intersection point, they're going to diverge from each other. So you can only have one intersection point. That intersection point might be on the axis, might not be on the axis. You cannot say that for sure.
so y axis এ থাকতে পারে না
Y-axis থাকতে পারে if for a certain set of for a certain scenario they can exist on the y-axis. For example, if I go for a bit control Z, let's say if I do draw the graph number 4 like this, so it is possible that graph number 3 and 4 are having the same
intersection
having the same intersection value.
yes
So or in other words, you can say that both of these lines pass through a single point. Both of these lines, I'm gonna label this as 4. I should label this as 4 first before I go for more jibber jabber. So we can say that both line 3 and line 4 has this cutoff. So for both of these points, they have a common point that can be labeled, that can have a coordinate of 0, minus c. You can say that.
আর যদি স্যার যদি ইন্টারসেক্ট না হয় তাহলে কি গ্রাফ 2 আর 1 এর মতো হবে নাকি যদি ইন্টারসেক্ট না করে
Well, দুইটা straight line যদি if you do not give range to the straight line equations, if you assume two straight lines are long infinitely, then they will definitely intersect only if they are not parallel. Parallel lines are never gonna cross.
yes
But as long as they have some angle between them and they are not limited by their value, which means they can be infinitely long, they will always intersect at somewhere. That location could be close to us or our observation, that location could be far away from our observation, but there will always be a definite point where both of the lines will cross each other, as long as they are not parallel and not limited by their range.
yes
Beautiful. Okay, so we covered this idea for the straight line equation. One additional thing that I should tell you, that this is one expression for a straight line. One expression for a straight line, but there can be many other different expressions for straight lines. For example, it is a straight line এক টাইপের এক্সপ্রেশন, স্ট্রেট লাইনে আর টাইপের এক্সপ্রেশন আছে যেগুলো তোমাদের অ্যাকচুয়ালি আমাদের ফিজিক্সের জন্য লাগবে না, ফিজিক্সের জন্য আমাদের এগুলো নিয়ে কাজ করলেই হয়, বাট আমি জাস্ট তোমাদেরকে বোঝানোর কমপ্লিটনেসের জন্য বলতেছি। Straight lines can also be written in this format: x plus by equals to c. This is also an equation for straight line. Straight lines can also be written in this format: x by a plus y by b equals to c. All of these three expressions can be equally applicable for straight lines. The only thing that you need to observe to determine whether a certain equation is for a straight line or not is that the power of x and y, these two locations, should always be 1 and 1 only, not equal. 1 I mean x to the power 1 and y to the power 1. দেখো এখানেও আমাদের y এর পাওয়ার কত?
1
Nothing is written, which means what is the power?
0 0 নাকি 1
y to the power 0 হলে তো 1 হয়ে যেত।
1
If y is only written as y means y to the power 1. So the power of y over here is 1, power of x over here is also 1, which means this is a straight line equation. Similarly over here, similarly over here. Equal doesn't mean that. For example, if you have an equation that looks like this, if you have an equation that looks like, let's say root over x by 3 plus root over of y by 4 equals to, let's say, 9. Here you can see that both of the x and y have a power of half and half, but this is not a straight line equation. For an equation to be straight line, both x and y power should be only 1. There should not be any other power involved. Yes, Ahmed Ibn Zayed Nuhan, bolo.
আর পাওয়ার যদি নেগেটিভ হয় তাহলে কি করব?
আচ্ছা, পাওয়ার নেগেটিভ হলে কি হবে সেটা আমি বলতেছি। পাওয়ার নেগেটিভ হলে আমাদের ইকুয়েশন কার্ভ হয়ে যাবে, ওটাতে আমি একটু পরে আসতেছি। আসতেছি, I'll discuss that part. But for straight line, this much is covered. So I'm gonna move on from the straight line part and slowly get into the curve equation. So I'm moving on to there. And if you have any question, please raise your hands. Yes.
Sir, can you just repeat what you just said a couple of minutes back about the straight line being having the power 1?
Yes.
Sir, I didn't understand that.
Oh, what I meant is that, let's say you are given a random equation, okay, and you're trying to judge whether that equation is for a straight line or not. All that you have to observe is whether the power of x is 1 and also power of y is 1. If that is the scenario, then you can confidently say this is an equation for a straight line. Or if we plot that equation with multiple x and y values, it will give us, for example, let me write some example for you. Let's say 6x plus 3y equals to 19. This is a straight line equation. Or if I write y equals to 4x plus 3, this is a straight line equation. But if I write, let's say in some other case, let's say if I write y equals to half x square plus 9, this is not a straight line equation. That's what I meant.
Sorry, I understood now.
Beautiful. Examples always help. So yeah, that works.
The power of c does not matter.
No, the constant really doesn't matter. The constant essentially tells you, I mean, in any case, you have your equation that looks like this. I mean, if you have your expression, if you have any equation for any geometric shape, stroke, square, or curve, if you have your equation where y is subjected means y was freed from everything else. There is no multiple, the power is also 1, which means the coefficient is 1, the power is also 1. If you have a situation like this, then this number always means the intercept value. Intercept value means এই কোশ্চেন থেকে যদি দেখি আমরা, if you place x equals to 0 over here, how much you're gonna get? Let's see, if you place x equals to 0, half into 0 square, what do you get? What do you get over here? If you place x equals
Sir,
to 0.
can
If
you
you
repeat the
place-
question?
If you place x equals to 0 in this equation, y equals to half x square plus 9. In this equation, if you place x equals to 0, what should you get as y value?
9.
Square,
equals to 9. Right?
half plus 9.
Y equals to 9, which means that this coordinate that we can get from that equation is that coordinate should be 0, 9. Which means if you make your y absolutely free of everything means its power is 1, also its coefficient is also 1. In that case, that number would give you the y-axis intercept. It means what is the exact coordinate, or what is the exact location where, what is the exact location? What is the exact location where the graph, curve, or straight line that cut across the y-axis? If this number is a positive 9, it means it will cut through the y-axis at location 9. If it is minus 9, it will be minus 9. If it is minus, let's say 4.33, it will cut across the negative y-axis at minus 4.3 location, blah, 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 so on and so forth. Yes, Adiba Amira.
Sir, what if the segment doesn't ever touch the y-intercept?
বুঝিনি, আবার বলো।
If the segment doesn't touch the y-intercept.
Oh, the segment might not touch the y-intercept if you apply some value for the x value. If you limit the value of x with some specific range, for example, something that was mentioned over here, then it is possible that the graph might not reach up to the y-axis. For example, if I give you an equation, let me just elaborate this piece a bit more. Let's say if you have an equation, let's say, তোমরা কি ম্যাথসে সার্কেল পড়ছো? Anyone? Circles, did you come across this yet?
Yes, sir.
Some of you might not have. It doesn't matter. Have a look. If I write the equation of a very simple simple circle, let's say if I write the equation of a circle that looks like this: x minus 3 whole squared plus, let's say, y minus 4 whole squared equals to 2 squared. This is a generic shape for a square, for a circle. This equation means that the center of this circle is going to be 3, 4, and the radius of this circle would be 2. That's what this equation means. How does that equation mean? I'm not getting into the discussion. Believe my words. Take my words for granted for the time being. Now, if we have a situation like this, and if you have a coordinate system, if I give a count, hello? I'm trying to find out who is from whose channel we are having the noise or not. Okay, so if I give it a count, let's say 1, 2, 3, and then 1, 2, 3, 4. The center of this circle is going to be located here, and the radius of this circle is going to be 2 units. So I might as well draw a circle of 2 units radius. So I should have this circle slightly bigger. Okay, somewhere over here, and this should get bigger, and this should get bigger as well. This is how much the circle is gonna be. See if you can make sense. So what I'm trying to show you is that the origin location of this circle, let me just label this with green. This is the origin of the origin, the center of this circle. It has a coordinate of 3, 4, whereas the radius in any direction would be 2 unit. Now I conveniently draw the 2 unit in this direction, so I observe these things to be 2 division below. So did I draw it to 1, 2, 3? Oh, sorry, my bad. I messed it up. Did you understand why what did I mess up? Hold on, respond.
So you give the radius 3 units.
I get the radius 3 on this side and 2 on this side, which is wrong. So 3, 4 is the coordinate, radius is 2. So let's say the circle is gonna look like this. So 3, 4 and radius 2. So something like this. Not a perfect circle, but scalable within my hand-drawn coordinate. So the center of this coordinate would be 3, 4, and the radius of the circle would be 2. But here, have a look. This curve, this is a shape of geometric shape that will never touch any of your axes. Do you see? Is it cutting across the x-axis? No. Is it cutting across the y-axis?
No.
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 Now, if you wonder, can we ever make this information available without drawing the graph? And the answer is very much yes.
No.
Have a look. If you place this number over here, let's say x minus 3 whole square equals to y minus 5. If I place the value x equals to 0 in this equation, try to think about this. I'm going to try to replace x equals to 0 to find out the y-axis intercept. Because x equals to 0 মানে হচ্ছে y-axis, তাই না? Think. X equals to 0 means what? The y-axis. And y equals to 0 means the x-axis.
X-axis.
So if I place x equals to 0 over here, I'm going to get what? 0 minus 3, that is minus 3 whole squared, plus y minus 4 whole squared equals to 4. So I might as well write y minus 4 whole squared equals to 4 minus 9. So wonder minus 9 cannot? Because minus 3 whole square gives you what?
9.
9, and you do the side change, it becomes 9. So what you are getting? You are getting y minus 4 whole squared equals to minus 5. Now this is highly unacceptable. Why is it unacceptable? The square of any real number cannot be negative.
We can't have a square root of a negative.
Exactly. The square of a real number cannot be negative, which means the x coordinate 0 does not belong in the acceptable range of this equation. But if you put any other point that belongs on the y-axis, you can find out that positive coordinate. For example, if you place x equals to let's say 1, 2, 3, you should get y equals to 2.
স্যার আপনার সাউন্ড ইকো হচ্ছে
আমার sound echo হচ্ছে because আমার sound echo হচ্ছে because some of our classmates have their channel on. They are not talking through their channel, but their channel is adding noise to our channel. All right, I have muted everyone so that is not a problem. If this problem persists, I will discard the option to unmute yourself so that I will only mute you manually whenever you raise your hand. Okay. Yes. Akem Sami, please ask a question.
Sir, yeah, I only want to know that when there is a power, মানে যখনই ওখানে স্কয়ার হবে কোন ইকুয়েশনে, যদি কোনো স্কয়ার থাকে তখন তো এটা লিনিয়ার থাকে না, তাই না?
ট্রু। শুধু স্কয়ার না, 1 এর থেকে ডিফারেন্ট কোনো কিছু থাকলে লিনিয়ার হবে না। স্কয়ার হইতে পারে, কিউব হইতে পারে, হাফ হইতে পারে, 0.25 হইতে পারে, মাইনাস হাফ হইতে পারে, anything other than 1 will make it a curve.
জি স্যার, ঠিক আছে।
Okay, good. So let's say we are so this is the part that I wanted to discuss, and before I get into the curve, acha, let me just get into the curve. Curve equation গুলো আমি তোমাদেরকে একটু বুঝাবো, ভালো মতন বুঝাবো. I'll take some time through this process. Okay, আমি curve equation তোমাদের বুঝাই. I'm gonna get rid of this because I'm done with this discussion, so this figure is deleted. So green blackboard with one click. How beautiful. Pulaban, আমি তো অনেকক্ষণ প্যাকার করলাম. This is the first time you're actually trying to learn something from. This is about nearly 1 hour has passed. Give me some feedback. Which part of the lecture that you would like to change? Let me give you some choices so that it's easier for you to sort it out. You can add your choices as well. Choice number 1, sir, speak slowly. Choice number 2, sir, speak loudly. Choice number 3, you are boring, become interesting, or whatever else you want to add. So please respond. Yes.
স্যার আমি না এই যে কয়েকক্ষণ আগে ইন্টারনেটে প্রবলেম ছিল, সেটা আপনার কয়েকটা কথা শুনতে হয়নি, আপনি রিপিট করতে পারবেন?
না,
স্যার
it's okay. শুনো, আমি তোমাকে বলতেছি, any one of you, if you have a trouble regarding your internet connections or anything, yes, if you have a connection with the internet connection, or if you couldn't catch a part of a lecture, or in other cases if you ever join class slightly late because you finished another class from somewhere else, or you just woke up your sleep and you forgot that today you had a class and then you randomly remember.
আমি আগে
No, I'm not blaming you. I'm giving you a general instruction. You should start following the class from the point that onwards, because and eventually the entire lecture will be uploaded in the YouTube. You should take your reference from the YouTube lecture, and then you can ask me the part that you didn't understand. If you have any relevant question about those parts which you missed, you can ask me personally in my messenger window. I'll help you.
স্যার আপনার ইউটিউব চ্যানেলের নাম কি?
আমার ইউটিউব চ্যানেলের নাম মোহাম্মদ ফয়সাল। তোমাদের যে ফেসবুক গ্রুপটা আছে ওখানে আমার ইউটিউব চ্যানেলের লিংক দেওয়া আছে, but still if you cannot find that information, PM me. Do you guys understand what PM is? PM is private message, which means you send a personal message to me. Okay, I would like to take a small bit of feedback that what should be changed in my lecture for you to get a better grip of this thing from this 1 hour. You can speak to the channel or you can write in the chat window.
Sir, you were giving some options. Can you say them again?
Sir, speak slowly. Speak loudly. Then anything else. These are the 2 options that I most commonly get from the kids, so that's what I'm quoting. Or if you have any other recommendation, I'm open to things.
A bit organized.
Organized in the sense?
At a particular topic.
Okay, I am not entirely understanding what I should do to that because I cannot understand the.
আরেকটু slowly.
আরেকটু স্লোলি করলে হয়।
আচ্ছা ঠিক আছে, slowly can be I think achieved. As for the organization part, I mean, I think
kind of like fast, so that's not a problem to me.
Acha. What I believe is that the reason this part of the lecture that I have gone so far might appear for you to be slightly unorganized. Is it unorganized or disorganized? Organized.
Organized.
স্যার
বলো।
স্যার বলতে চাচ্ছি কি যে স্যার আমার মনে হচ্ছে যে স্যার যখন ক্লাসটা আমরা শুরু করি তখন একটু বোর্ডটা একটু বড় করে রাখলে ভালো হয়, কারণ হচ্ছে চিপাচিপি হয়ে যায় তো পরে আবার বড় করতে গেলে তো ওইরকমই থেকে যায়, মানে একটার উপর আরেকটা হয়ে যায়।
Oh, acha, boltesi. I don't usually start with a larger board for one reason is that what actually happened, because this is a very introductory class, I actually expanded 4 different equations, also the idea of gradient and everything onwards. I did not expect because I am a dumb person, definitely. I didn't expect that I would have to explain the idea of gradient to all of you. I assume that you all kids already know the idea of gradient because you have been through class 8. So, but I actually had to go ahead and explain the idea of gradient. That's why I required a bit more space than usual. But I get your point. I'll try to remember that. That's a very good point that you mentioned.
Sir, you're going too fast. You go too fast. I think you should slow it down. Slow the explanations down.
All right. I'll try to remember that slow down. Me to slow down is the most common recommendation that I get from nearly all of my students. So I have a humble request to all of you. Just a moment.
Sir, I personally have no problem with anything right now.
কি আছে
এই কোশ্চেনে তারপর
স্যার
স্যার কি আছে?
লাগে না
Are you there?
Sir, are you there?
Maybe
Hello.
connection.
I think network problem.
He's in a different room. He's in a different room. Just
হয়তো
chill.
হয়তো নেটওয়ার্ক হবে
Sir, are you there?
I went out to turn on my AC, but I couldn't find my remote. So I have asked for help. Help will be here. So I have a humble request to all of you. That is, if you ever feel like that I'm going too fast, that actually happens without me knowing it. So if you ever feel like that I need to slow down, ask that immediately.
Sir, I personally have no problems
Okay,
regarding
some of you might have some problems, some of you might not have some problem, but that's not a big deal. But as long as any of us, if you have any problem with me going too fast, ask me to slow down. It's perfectly all right. I know that I have this problem. So yeah, okay, I'm going to be muting all of you for the next part of the lecture. Okay, have a look. The next thing that we need to understand is how does curves look? The very simple expression for a curve can be given as y equals to k into x to the power n, where n not equals to 1. Try to appreciate this expression. I'm gonna be simplifying this, but this is the generalized version. If you have questions, raise hand. Otherwise, keep your channel muted. I'll give you floor with your questions.
K এর মানেটা কি?
Raise hands.
Awesome.
It's okay. In this case, both k and n represents a numerical constant, which can control how fast the value of x, how fast the value of x increases as the x value changes.
মানে যদি কার্ভটা মানে গ্রাফটা যদি মানে একটা কার্ভ লাইন থাকে তাহলে এটা ইউজ করা হয়।
Yes.
So question.
So y equals to k into x to the power n. Here the k and n, they are usually numerical values. Now we might also have some constant over here as k x to the power n plus c, which comes as the y-axis intercept, which is a very default thing. But I'm not going to be going through this whole part over here. I'm not going to be working with this large equation over here. For the convenience, I'll be taking the smaller part. Let's say I'm simply starting with y equals to x squared, which is a very simple equation to work with because we have numbers over here. So let's say I have y equals to x squared over here. Shreyas Labib, if you have a question, keep your hand raised. If you don't have a question, put your hand down. So y equals to x squared is the equation. So I'm going to show you how this graph looks like and how many of these other graphs look like by using a very special drawing device, which is available on internet. So I don't have to draw all of it by my bare hands, which is amazing. So this is how y equals to x square looks like. Now I need you to, all of you, to have a very good look at how this graph is shaped. I'm going to be zooming on this part. I'm going to be mostly discussing about what is happening on the first quadrant, because for most part of your physics relevant graphs, you don't have to bother about the other quadrants. So I'll be mostly covering my lecture for this segment. So I need you to keep your eyes peeled and try to make sense of it. Have a look. Y equals to x squared, if you try to think in your head that if you place the value of x equals to 0, you have 0 squared, which becomes y equals to 0. You have the 0, 0 point over here. The graph is passing through that point. Well and good. And also, if you place x equals to 1, you also get y 1 squared gives you 1. So this graph also passes through x equals to 1 and 1 equals to 1, y equals to 1. So 1, 1 is also a cross point. So you have 0, 0 and 1, 1 both. Now, because I want to give you a respective idea, for the sake of easy understanding, I'm gonna plot a graph of y equals to x over here, because we need that graph. I'm gonna put it on top. What I need you to see that y equals to x is basically the 45-degree angle line where both the coordinates of x value and y values are exactly equal. So for x equals to 0, you have y equals to 0, x equals to 1, you have y equals to 1, x equals to 2, you have y equals to 2. This is just a straight diagonal line that makes a 45-degree angle over here, because all of these triangles, if you think of triangles over here, all of these triangles are isosceles triangles. So this is the standard line. Now, have a very good look at what is happening here. You can see within the range from 0 to 1 of the x value, the y values are smaller than 1. This red graph, this segment of the red graph belongs below the blue line. This part of the red graph belongs below the blue line, which means whenever you are squaring an x value that is smaller than 1, you are going to come up with a number that is smaller than that number. So think about it. If you square, I'm going to write some values over here. So if we square, let's say, where is the pencil? Pencil is over here. Let's say if I square, let's say if x equals to 1, x equals to 0.1, then what should be the value of y? 0.1 squared. How much do you get? You get 0.01. If x equals to 0.2, you get y equals to 0.02 squared, which becomes 0.2 squared, which becomes 0.04. So on and so forth. So what I'm trying to show you, what I need to observe, when x is 0.1, relevant y value is 0.01. Between these two numbers, which one is bigger? X value is bigger, and y value is significantly smaller. So this pattern will keep on happening till x equals to 1 happens. At x equals to 1, y equals to 1 square equals to 1 happens. So for this entire region, the y value is somewhat smaller than x. Over this place, y equals to x for this exact value. Beyond this range, let's say x equals to 1.1. In that case, y will become 1.1 whole squared. That becomes 1.21. Have a look. This is 1.1 and this is 1.21. So y has now become bigger compared to x. If you give x equals to 2, y equals to 2 squared, you get 4. So the value of y is bigger than x. And this pattern will keep on happening over here. So for this entire region, as you go further down, y value is bigger than x. That's what I want you to observe in this graph. Have a look. For a range of x value 0 to 1, y values are smaller than the x value. That's why it is belonging to below this blue line. This blue line represents the equal values for both of them, y equals to x. So this is your sort of your reference. As your x value goes higher than 1, then your y values are slowly also becoming bigger than 1. You can see that all of these y coordinates are higher than the possible x coordinates. So they are all becoming bigger. So this is the shape of y equals to x squared, which is a curve, and that's how it works. So that's the first thing I want you to keep in your head. More parts are coming. If I now increase this power, if I now make this square cube, so what I'm gonna get? Let's write y equals to x to the power 3. Take a good look what is happening. Now you are also having the same behavior. Up to 1, the values are smaller. Above 1, the values are bigger. But here, the small numbers have become more smaller than y equals to x squared. For example, the green segment is below the red segment, which means, try to understand, for a value of x equals to 0.5, this red line represents 0.25. This is 0.25. If you wonder how, here is 0.5 x value and here is 0.5 on the y-axis value. So if for the red graph, which is y equals to x squared, this x equals to 0.5 reflects on the y-axis as 0.25 because 0.5 squared gives you 0.25. 0.5 cube gives you 0.125. So this value is 0.125. So it is 1. Have a look. 0.5 to ekhane. How many divisions do we have? 5. So this means 0, 0.1, 0.2, 0.3, 0.4, 0.5. So this is 0, this is 0.1, this is 0.2. So 1/4 of this box is 0.25. So here, somewhere over here, 1/4 above, you have 0. I shouldn't have it here. Somewhere over here, we have a 1.25. And that whole behavior continues up to 1. Exactly at 1, you have the same points once again because 1 cube also gives you 1. So 1 is a common intersect point for all of these three graphs. But as you go above, then your values of y equals to x cube start to become larger, more than the y equals to x squared. For example, if you think of it, come to think of it, when x equals to 2, y equals to x cube gives you what? 2 cube, which is what? 8. For y equals to 2 square, you get what? 4. For cube, you get 8. So if I go for this equation for x equals to 3, y equals for x equals to 3, y equals to 3 squared, which is 9. But for cube, for x equals to 3, y equals to 3 cube, which is 27. So what you can see that for the same x values, the square value is giving you a number, but the cube value is giving you even a bigger number. So that is essentially represented on this part of the graph, that whenever you have equal values plotted for the red or the green graph, the red graph is always taller compared to the red graph. For example, when x equals to 2, you have for the red graph, which is y equals to x squared, at 2 square 4. But for the green graph, you have 2 cube. Here, have a look, here is 8. And you can go further. If you zoom out this graph, you can get all of these values working like that. So these are the two information that I wanted to observe, that for the further increase you make to the power, this will become more, this will fall further below the 1 level, but above the 1 level, this will become steeper even faster. For example, if I add another equation just to convince you of this fact, if I write y equals to x to the power 3.5, I'm not writing even 4, I'm writing 3.5. You see, it's slightly bigger than this green line. If I make this 3.5, 3.4, if I make this 4, you see that is happening. It's becoming steeper, steeper, steeper. If I make this 10, it's even becoming smaller, smaller on the, I mean, this below 1 is becoming even smaller, and above 1 is becoming even steeper. So point to be noted is that, let's say I'm gonna keep this as 4, just to be on the safe side. Point to be noted is that whenever the y equals to x to the power, the power of x is somewhat bigger than the power of y, in those scenarios, your equations, your curves will have a positive increasing gradient. Now, what do I mean by increasing gradient? What I mean is something that I'll show you, but let me just, should I cut this off? Acha, increasing gradient আইডিয়াটা পরে বলছি, আগে তোমার স্ল্যান্টিং এর বিহেভিয়ারটা দেখো। গ্রেডিয়েন্টের পার্টটা আমি একটু পরে বলছি, কার্ভের গ্রেডিয়েন্ট আমি পড়াই না এখনো, একটু পরে পড়াবো, পড়ানোর পর বুঝাচ্ছি। So এই ইনফরমেশনটুকু হচ্ছে এখানে। Now I'm gonna go do the opposite change. Have a look. In this part of the discussion, I was slowly increasing the power of x. What if we increase the power of x, y, and keep the power of x constant? So that, in other words, would mean something like this. So here is the second part of the discussion. Let me draw this with, write this with blue. So first we discussed y equals to x, which was the straight line, which was the diagonal straight line, which was going through like this. And then we talked about y equals to x squared. What if we now talk about y square equals to x, and then we talk about y cube equals to x? What would this graph look like? What do this graph essentially mean? Y square equals to x can also be rewritten in the format of y equals to x to the power half. Check this out. I just did root over on both sides, mathematical operation. Y cube equals to x can be also rewritten as y equals to x to the power 1/3. So here, as you can see, compared to those equations in red, here the behavior is that here, I mean, if you have an observation of the x value changes in this sequence, what is happening? Here the x value was 1. Here the x value is half. Here the x value is 1/3, which means that now we are, if we keep the y values equal, if we keep the y intact, the power of x is slowly becoming smaller. But I'm not going on the negative side yet. I'm still keeping it fraction. Negative side part ta pore boltesi. I'm not still making it negative. So this is the type of power that we are having. So y equals to x to the power half is the same equation as y square equals to x. So I can plot this graph or I can plot this graph. Both of these graphs should look identically same in our software. So I'm going to be showing you both of these graphs just to convince you of this fact. So so we drop another graph. So I'm going to write y square equals to x. Check this out. What is happening? This graph is starting to increase. As x value increases, y value is also increasing, but it is increasing more compared to the x value beyond 1. So this graph is going out like this. So slowly it is becoming more and more slant. So take a good look at the shape of this graph. I mean, have a look at this part of the gradient. Have a look at this part. Try to observe this part of the graph. You have the y equals to x as the blue line. As your x power becomes higher, the lines become more steeper. As your x value has become less than 1, the line slowly starts to fall below this line. And as you can see that this gap is slowly becoming large. Do you see that? Which means this gradient is slowly becoming less. Now, why would this become slowly less? I'm going to explain this in a bit. So this was y square equals to x. Now, what I told you a bit earlier, y square equals to x and y equals to x to the power half should give us the same graph. Let me convince you of this fact. So I'm going to write y equals to, where is y? Y equals to x to the power, where is the fraction writing option over here? Acha, half means 0.5. So I might as well write 0.5 because I cannot write fraction in fraction form. So I'm writing this one. Have a look. This graph is supposed to be red. This graph is supposed to be black. Do you see that the black graph has completely vanished on this axis? The reason it has vanished is because this is just below this line. These two lines got overlapped. And that's why we cannot see the black line. However, I can make this black line show up if I just change this number by a little bit so that they will be slightly different. For example, let's say I make this number 0.6. Take a look. Now this y equals to x line is over here. Y equals to x to the power 0.6 line is showing up over here. Point to be noted. Whenever the power of x is smaller than y, the graphs tend to change shape in this fashion. What fashion? In this fashion. Whenever the power of x is bigger than the power of y, graphs tends to change if you change their shape like that. So rule of thumb, coming to the conclusion of this part, then I'm going to start taking questions. Rule of thumb is that okay, I have enough space. I just have to move to the right. Rule of thumb is that if you have an equation, let me write this with black. If you have an equation that looks like this, let's say y to the power m, let's say y to the power a equals to x to the power b. Let's say this is an equation that you are trying to assume the shape for. What would be the shape of this graph? If it is the case that a is smaller than b, a is smaller than b means the power of y is less, power of b is more. For example, y square equals to x cube, y to the power 99 equals to x to the power 100, y to the power 2 equals to x to the power 2.001, even slightly bigger. If a is smaller than b and b is slightly bigger, all of these graphs will have a shape like this. Slowly it will be bending upwards. If it is like that, so where the y power is bigger and the x power is smaller, those graphs will have a shape like this. And it is important for you to understand as well is that this graph, both of these graphs for this segment, for over here or over here, the starting of the graphs will always start being tangent with the axis. For example, this graph will start being touching the x-axis over here. So touching the x-axis means what? Let me elaborate that point and then I'll start taking questions. So let's say have a look at two graphs. So I'm trying to draw over here minutely. This is a graph that starts being tangent with the x-axis, whereas this is a graph that does not start tangent with the x-axis, but they both have increasing gradient. This equation will never give you this kind of setup. This equation will always give you graphs or curves which will always be either tangent with the x-axis or they will always be tangent with the y-axis as they start. But slowly they'll be starting getting away from the axis. I can convince you. Have a look at the very axis side over here. Have a look at this zoomed vision. You can see it very clearly. I'm zooming in really, really hard. So the numbers have become extremely small. I mean, the more I zoom, you'll see that all of those lines for the initial part, they are all starting tangent. For the equations 1, 2, 3, 4, all of them are starting being tangent to the x-axis. For the equation 5 and 6, they're starting being tangent to the y-axis, and then they're slowly getting further apart. And eventually after they are all passing through y equals to 1. That is a given, and then they're gonna go by. Now this logic that I just told you, let me show you a proof of this. So let me choose some two random numbers out of my head, and then if you want, I can draw some numbers from your head. So let's say I'm gonna make an equation of y equals to y to the power, let's say not squared. I don't want to give squared. Let's say y to the power 25 equals to x to the power, let's say 22. You see, this is the dark blue line, which is belonging above the original y equals to x light blue line. Because this part is above, which means beyond this point, this line is becoming below. So this is not a straight line. This dark blue color, I mean, you can see that it's not a straight line. If I zoom it out even further and further and further, have a look. This appeared to be a straight line, but it is not a straight line. This is a straight line. Have a look. You can see this is not a straight line because it's not cutting across the same number of divisions. You can see that it's going down further and further and further. So that's the part that I'm trying to mean. And if I also change these numbers, for example, if I change these values, for let's say if I make this, let's say 100, and make this number 99, not 99, no, not 99, sure, 100. This equation software doesn't want to work with 100. So let's say if I place, let's say y equals to 50 equals to x to the power 55. You see, now you're having this line to have an increasing gradient. Now this line has become above the y equals to x line beyond the x equals to 1 region. So up to x equals to 1 region, it is below that line. Have a look. This is your light blue, this is your dark blue. Let me can I change the color of this one? I cannot change the color of this one. It's just becoming the same color. So okay, I can only work with these numbers, this number of colors. Okay, let me just take this, let me just make this gone and bring this up. Okay, just to make sure that this black line is what we're talking about. So that was the description that from my part. Summary, this part. How the graph is going to be shaped depends on the comparison of their powers. I'll take questions from each of you. So one by one. Arif Aryan, you can unmute yourself.
স্যার আপনি যে এখানে একটা লিখছেন না যে when a is greater than b, তা এই গ্রাফ চেঞ্জেসটা কেমনে হয় সেটা বুঝতে পারি নাই। মানে যে আপনি একটা গ্রাফ এঁকেছিলেন না যে when a is greater than b, হ্যাঁ এটা বুঝতে পারি।
I did not go through the plotting process. To avoid the individual plotting of this graph, I took help of this plotting calculator. So whenever y equals to a is greater than b, it means, let's say, y equals to x square. For example, this one, y equals to x to the power 0.6. এখানে y এর power হচ্ছে কত? 1.
একটা
1 আর x, the power of x is 0.6. So 1 is bigger than 0.6. So you are having a graph like this.
তো সবকিছু 1 এর দিকে ইন্টারসেক্ট করতেছে কেন? সবকিছু
Because there is no plus anything over here. If you place the value of 1 over here, 1 to the power anything gives you 1. 1 to the power 1 gives you 1, 1 square gives you 1, 1 to the power 1.5 gives you 1, 1 to the power 3, 1 to the power 1000 gives you 1. Power of 1 always gives you 1.
পাওয়ার যদি যত বেশি হবে তত গ্রাফে মানে লাইনটা কি হবে? যদি যত নাম্বার বেশি দেওয়া হবে
গ্রাফটা তত বেশি কার্ভড হবে. The difference between the two powers will determine how much curvature are you gonna get.
Oh, এটা
হ্যাঁ,
যদি মানে কম হয় তাহলে কার্ভটা আরো কম হবে.
Exactly. For example, over here for y equals to x, the difference of these power of these two numbers is what? 0. You have a straight line. For y equals to x squared, the
আগে দিক দিয়ে যে কার্ভ হইছে 1 এ বিফোর ইট ইন্টারসেক্টেড 1, তবে আগে তো সবকিছুই কার্ভ ছিল. তবে যখন 1 টাকে ইন্টারসেক্ট করছে তখন এই সব সোজা হয়ে গেছে. এটা আর কেমনে সম্ভব?
কোথায় সোজা হলো? এগুলো সবগুলো কার্ভই আছে.
না
এখানে কার্ভ
আপনি জুম করছেন সেজন্য বুঝছেন.
মানে আমি তোমাকে বোঝানোর জন্য জুম আউট করতেছিলাম, যে দেখানোর জন্য যে কার্ভ অ্যাকচুয়ালি আছে, বাট এই কার্ভগুলো বোঝা একটু ডিফিকাল্ট. আমি তোমাকে কার্ভের শেপটা কার্ভটা বোঝানোর জন্য জুম আউট করতেছি. This is the straight line. Have a look. This is the straight line.
Yes.
But all of the other lines that you can see over here, they're all curves. All of them. That's what I meant.
Oh. Okay.
বুঝা গেছে?
আর যদি মানে এই মানে b is greater than a তাহলে কি মানে একদম মানে একটা ছিলেন না, মানে if b is greater than a,
দেখো এখানে কি শেপটা আঁকা আছে?
Curved. এটাও
both of them are curved, but they have different shaped curve.
হ্যাঁ, মানে accelerate করতেছে, মানে বলতে পারেন যে accelerate করতেছেন. যদি
I wouldn't go for the term of accelerate করতেছে, because I haven't yet entered into the kinematics chapter, but I'd say that for this curve the gradient is increasing because the line is becoming more steeper.
তারপর আপনার একটা ফর্মুলা যে এটা করছিলেন না, y equals মানে একটা ফর্মুলা দিয়েছিলেন y equals to kx, এরকম একটা ফর্মুলা মেনশন করেছিলেন.
Yes.
এটা কিসের জন্য ইউজ করা হয়?
ওটা পর্যন্ত এখনো যায় নাই.
না, কিন্তু আপনি গ্রাফ মানে ফর্মুলাটা তো মেনশন করছিলেন.
হ্যাঁ, সো আমি মেনশন করছি, বাট এটা এক্সপ্লেনেশন পর্যন্ত এখনো যায় নাই. I have only covered up to this part. I have only covered up to y equals to x to the power n part. I have only covered this equation, or to be more accurate, I can say y equals to a equals to x to the power b. I have only covered up to this part. I'll be slowly getting into this equation, these parts as well. I'll add them up a bit later.
Okay.
As the lecture goes forward.
Okay, all right. Thanks.
Sure, no problem. Fabiha Reem.
Sir, I have 3 questions. What happens if the power of x is less than 1?
Yeah, you cannot effectively say, I mean, what happens to the power of to the graph when the power of x is less than 1? What really matters is the comparison of the power of these two variables.
And sir, what did you say about the tangent to the x-axis? I didn't understand that part.
Oh, that part is pretty simple. Acha, ঠিক আছে. I get your question now. That part is not very simple. I haven't yet described the tangent part. I'll show you in a bit, right after this one, how to calculate that gradient of a curve. Right after this one, then it will become easier for you to understand. Don't worry. I'll explain that for you.
Okay, and the other question was the x equals to 1 region. I didn't understand that part either.
Which part?
X equals to 1 region. That part. Those were your exact words.
X equals to 1
region. Yeah, something about the graph.
Oh, that part means that for equations like this, because there is no multiplier or coefficient in front of this part. I mean, I didn't write y equals to 2x. I only wrote y equals to x. So no matter what power you give above the x, as long as x value is 1, all of those results would be 1. X to the power 1 gives you 1. X to the power 1, oh, sorry, 1 to the power 1 gives you 1. 1 to the power 2 gives you 1. 1 to the power 3 gives you 1. 1 to the power 4 also gives you 1. So irrespective of these different powers over here, all of these curves will have to go through the 1, 1 point, because 1, 1 point comes out of all of them. So all of these curves that you can see over here, they are all passing to the 1, 1 point. That is common for all of them because of the shape of these equations. Because 1 to the power anything gives you 1.
Okay, so I understood.
Beautiful. Kids, point to remember, on our next class, I'm going to be finishing the class. I'm telling you what I'm going to start on the next class. On our next class, the first thing I'm going to explain is how to calculate the gradient of a curve. And then I'm going to talk about the horizontalness and the verticalness. So if you remind me at the beginning of the class that I'm supposed to show you how to calculate the gradient of a curve. That's the first topic we're going to start by. And I declared that the class is going to be up to 4:30. I have already kept you 8 minutes additional, and I appreciate all of your patience, and thank you very much. I'll upload the lecture on the YouTube channel after a little while. The channel is mentioned in your Facebook group or if you cannot find this, you give me a personal message. I'll share the link. No big deal. Thank you, kids. Bye. Oh, there are people who are trying to participate. Yeah. I have allowed the option to unmute anyone. Do any of you have any question?
The next class স্যার কালকে হবে না?
নেক্সট ক্লাস কি কালকে পড়ছে আমাদের মঙ্গলবার, আজকে তো সোমবার। হ্যাঁ কালকে, কালকে 5:30টায়।
জি স্যার, থ্যাংক ইউ।
Sir,
বলো।
Thank you.
which topic is like this topic, the thing that we had a class today on? Like which topic?
You will be requiring the information regarding graphs in pretty much every chapter where you have to do some mathematical calculation. But the first chapter where you will get to practically use this information is the motion chapters, velocity, acceleration, time graphs, those things. That's the first chapter where you can use this information. But you will have to be able to use this information in a lot of upcoming chapters as well. So this is a generic knowledge that you will require.
Oh, okay, thank you.
Sure, no problem. Sumaya, do you have any question?
Yes, sure. Will you explain all the graphs going through one more time?
Oh, because try to think of it. Try to find out the y value when x equals to 1 for any of these equation. You can use a calculator for all I care.
Sure, I didn't understand your question.
Try to find out calculate the y value when x equals to 1 from any of these equations. I mean, what is the y value if x equals to 1?
1?
For all of them?
No. I guess.
You should calculate. Use your calculator to find out for the second one. Type in your calculator 1 square. What do you get?
1.
1 cube. What do you get?
1.
Yes, sir? Yeah, 1.
Then 1 to the power 4. What do you get?
1.
Then 1 to the power 55. What do you get?
1.
1 to the power 0.6. What do you get?
1.
Which means if the x value is 1, irrespective of the power of x and y value is always what?
1.
Which means 1, 1 is a point through which all of these curves should pass through.
Oh, okay. I get it now. Yes, sir.
That's the intersection point, right?
That's the intersection, exactly. That's one of the intersection point, and the 0, 0 is a default intersection point because 0, 0 is default.
Okay.
All right.
Yes, sir.
Okay, beautiful.
Yes,
Thank you
sir.
very much.
Bye.
You're welcome.
Bye, sir.
Bye.
Bye, sir.
Hey, sir.